back on now. We have done the sort of, so to speak, the preparation, the mathematical preparation. So we're getting into physics. We call this thing physics. It took 20 of us to get here. Now we're taking a look at this, looking at physics. First, what we are going to do here, at least what I plan for now, is just the motion of an object. We're going to take a look how an object moves. And first, we're going to look at this object moving, let's say, on this plane. We're going to, for instance, this pen, right? We're going to move on this pen like this, like so, not turning. I'm going to push this pen. Well, yeah, there's resistance in here. It doesn't really work. Let's say push this piece of paper. Okay, yeah, it's okay, right? We'll push this piece of paper in a way that the thing doesn't rotate. That means when I push it, I'm pushing the center of gravity or the center of mass in this way, right? Okay. When I do that, we can treat any object as a point because it's not turning. There's no internal structure, doesn't matter. Okay, when we draw object, we're gonna draw it big, but you treat this as a point. For instance, here is a surface. Then we put an object on it. Right, this object has a size, but we are gonna ignore all the internal structures of this. We treat this as a point. Okay. Until we deal with the rotation, until this thing starts to rotate, that we cannot treat as a point. We may equivalent to something, but we're not going to get into that. The center of mass normally is somewhere in the middle. It doesn't really, for our purposes, as long as it doesn't rotate, doesn't matter where it is. So when it has a force on it, we do it this way, because it's the center of mass taking a force. But when it happens, it can be you're pushing it, you're pushing it here, right? You can be pushing it. You're pushing it from here, right? Yeah. But it doesn't really matter. We're gonna draw it this way. At any given moment, we're interested in knowing at any given moment where this thing is. Okay. So far, so good, right? And at any given moment, what is the speed of this? Okay, that is dx dt, right? Yeah. When the speed comes up with the velocity, let's say it goes, the speed goes this way, right? It's a vector, and that vector is called velocity. Of course, velocity can change in time. This is v, right? So we have dv dt. Velocity's change in time is called acceleration. Yeah. Now we call it acceleration. This is velocity. Okay. That is, you're doing x twice. Okay. Yeah. Okay, we're gonna do a very, very simple thing, which is a is constant. How this thing gonna work out? Yeah. If a is constant, dv dt equals to a. If this is a constant, we put the t over. When you solve this kind of thing, you always put a v on one side, a t on the other side, take an integral. Yeah. Right? Because the dv on this side, dt on the other side, right? Since a is a constant, doesn't really matter where a stays, right? Right? Yeah. It's just v equals to at, right? Yeah. Of course, plus a c, okay? Plus a c. Okay. Now let's look at what c is. You get where the c comes from, right? That constant comes from, right? Because think about take a derivative of this. This becomes dv, right?
Yeah.
This becomes dt, right?
Yeah.
C goes away, becomes 0. Because any constant you take a derivative becomes 0. Following?
Yeah.
So when you go back, there's always a constant. That when you take a derivative, you lost it. So when you take integral, there's always a constant. Okay? T equal to 0. Okay, when t equals 0, v equals to c.
Yeah.
Did you get it? So I'm going to write this in a slightly different form. We say v equals to at plus v, which is called sub-zero. This is velocity equals to at the time of 0.
Okay.
So in other words, I can give you a problem and say the accelerations whatever, and this thing at the beginning, the velocity is whatever. I want to know the velocity of the function velocity at any given time. 3 hours, how fast this. Well, anyway, let's say a car, right? I tell you it's accelerated at a certain speed. At the beginning is not moving. You want to know the velocity, say 3 seconds later. Right? Same car, same acceleration. Let's say it moves at 60 miles an hour already. Then it wants to do the same acceleration. 3 seconds later, it's definitely a different velocity, right? Because you're already that fast. And whatever that is, the derivative, this equation is always the same, right?
Yeah.
In other words, the initial condition, it matters. We're talking about the constant, we just ignore the constant basically, right? We just carry a c, we didn't really talk about it or whatever, right? This is called boundary conditions. When you have a differential equation, the boundary conditions, this is, time of 0, whatever, it matters. How do you start this thing? You remember you remember that chart with all the slopes everywhere?
Yeah.
Yeah. For this one, dv dt is everywhere it's the same. Okay? So any dot, this slope is just a. Let's just call a equals to 1, right? Slope everywhere is this. Everywhere is this. So
Yeah.
you give a dot, it'll move in that direction. You give a dot, it'll move. However, this is the initial condition. This is different.
Yeah.
Yeah. Okay. You know that e to the power x thing, right? It always come down, right? Initially, you have to be 0 to stay on the 0 line.
Yeah.
Otherwise, it will never get a 0. In other words, if you're infected, you'll never get completely cured, kind of thing. Unless you initially you just keep clean, you're clean. Yeah. Okay. We're gonna move on. Now we have the v. Now we want to solve for x.
Okay.
dv is dx dt, right? Equals to at plus v sub 0. Okay.
Okay.
How do you solve this one?
Like for t or
Hmm?
for x.
Yeah. When we're talking about this derivative equation, when we want to solve it, what's the first thing we want to do?
Don't you just integrate both sides?
How do you do it? There's still dt on this side. There's still t on this side. How do you integrate?
Oh, just multiply dt over and then integrate.
Okay. I want to make it clear that to solve these kind of equations, first thing you want to take out is the derivatives. Okay. Get into this form. F x y equal to 0. In this case, f x t equal to 0. Then you go to clean up or whatever it is that you do. Okay. And to solve this, when we talk about this, right?
Yeah.
You put x on one side and put y on the other side. Yeah? In this case, you look at this. This t is still on this side. You want to put the t on the other side. Okay? So dx equals to AT plus V sub 0 dt, right?
Yeah.
A V sub 0 constant, because we just said A is constant, right? Not nothing over T. Can just take right out. So X equals to what? What's this term?
Is acceleration and velocity known?
No. Just AT dt. When you take an integral, what is it?
Oh, it's AT squared divided by 2 plus velocity
Okay,
squared
AT.
divided by 2.
Okay. AT squared. Okay. AT squared divided by 2, right?
Yeah.
Okay. And what?
And then velocity squared divided by 2.
Velocity squared.
Wait, no, velocity times x.
Velocity times x. Really?
Wait, is velocity a constant?
Yeah. Oh, no. This is velocity at time 0. Velocity is not a constant. But this one is velocity at time 0. Of course it's a constant. Velocity is a certain time. Okay. So what is it? Is a v sub 0 x? What variable are you taking integral on?
Oh, it's v times t.
Yeah.
Sorry.
Plus a constant, right?
Yeah.
Now we have experience with this. This constant is where x is at the time 0.
Yeah.
Right? Time 0, x equals this, the constant, right? We just call it this. Right?
Yeah.
Okay, now this is actually very easy to understand. That is, if you accelerate something, this thing is going to go faster and faster, right? Okay. Let's say this stuff is velocity. The v0 is 0, x0 is 0. Then x equal to this, right?
Yeah.
And you know the distance. You want to know how long it takes to get there.
Okay.
Yeah. So I'm gonna multiply this up. Let's see. We're gonna do this. That actually doesn't give us much. Anyway, for this relationship, you want to know distance and the time of t, right? You give a distance, you want to know where the thing is. So t equals to 2x divided by b divided by a, right?
2x.
T equals to 2 multiply up, right?
Yeah.
2x, a go divide down, right?
Yeah.
2x divided by a. That, right? You take a square root. This is you give a distance, you want to know how much time it takes to get there.
Yeah.
Yeah. Let's say you want to know what's you give a distance, you want to know what's the velocity, let's say.
Wait.
If you know the distance, the movement, this, forget about this, right? This is all 0. Make it all 0.
Okay.
Just make it simple. I give you a time, right? No. I give you a distance. I say for a car to accelerate, let's say, right? Say whatever, 500 yards, or let's say 10 yards, right? How in 10 yards, like how much time does it take? You do this, right? This is 10 yards. This is, well, we should use meters because this is all in meters. Because if you use any other unit, there will be a constant to convert it. So it's supposed to be to convert it into meters. If you use meters, there's no constant. Just x is 3 meters, a is whatever. By the way, the x, the unit of x is meters, right?
Yeah.
The unit of x speed is, velocity is,
Meters over seconds
okay. And the acceleration,
is meters square over second.
meters squared over second.
Yeah.
Meters squared over second. Look at it.
Yeah.
Meters squared.
Alright, meters over second square.
Okay. Now, I give you a distance. I want to know the velocity at that distance. How do you calculate that?
Well, I know the velocity at that distance.
When v0 x0 are 0, let's say, how do you want to do that?
Don't you just like plug it in like this equation?
Yes, very simple. I'm not. Yeah, yeah. Okay.
I feel like you're
Didn't
trying
screw
to
up
trick me.
I'm not tricking you at all. A 2x a equals to 2x. Okay. Okay. Now, x times distance, velocity, whatever. You know one. You know everything.
Yeah.
Because you essentially you understand how this thing moves, and you know one thing, you know everything else. Yeah, because when this moves, right, at any given time it has a velocity, it has a position, it has a acceleration is fixed,
Yeah.
and it has a time. At any time, location and velocity all change. So you know one, you know the if you know the time, of course you know the position and you know the velocity, right?
Yeah.
You know the distance, you know the location, which is x, you know the time, you know the velocity, right? If you know the velocity, of course you know time. That's probably kind of, you know the velocity, of course you know where it is. You know the let's see, you know the velocity, you know the time, and you know the time, you know where it is. Right? You can substitute this, t equals to v over a, right? You can substitute this into this.
Yeah.
Wait a minute, what are we talking about? If you know velocity, you know location, right? Yeah, the t equals to v over a, right? You put it in here, this become a function of v. This become v, right? In other words, x equals to, let's just do this. X equals to, this is a v squared divided by a squared,
Yeah.
right? So it's v squared divided by 2a. Right? This is t equals to v squared divided by a squared. T equal to v squared divided by 2a squared. T equals to v squared, v divided by a.
Oh yeah. Okay.
Then t squared equal to v squared divided by a squared.
Yeah.
Then 1a takes out, that becomes this.
Okay.
Yeah. So, and also t equals to v divided by a. Right? So you have a velocity, you can get a time and position.
Yeah.
You have the time, you can get it into velocity and position. And you get a position, you can get the velocity and time. See, this is obviously, right?
Logic, yeah.
Because once you know this motion,
Yeah.
you need to give me a time, right, to know where it is, right? Otherwise, this thing is moving, right? However, you can give me all three. You give me one, you get two. The other two,
Yeah.
you know, they can come up with all kind of funny problems in that regard, right? When you take a okay, well, let's see. We are not going to do any problems. Do you want to do some problems?
I'm good.
Let's do problems. Let's see. Probably it's a lot of time already. Okay, it's still a little bit early, but okay, just do one problem, very simple, and some problem that we have seen before. That is an object with a mass of m on an angle. Let's call this theta, right? Yeah.
Yeah.
And of course, there's a gravity. G is gravitational acceleration, right? This gravity, it moves faster and faster.
Yeah.
And for all of our purposes, it's constant. It's not a constant, obviously. It depends on how far you're away from the Earth, the center of the Earth.
Yeah.
This is further away than this, but it's so close. There's no big change. So unless you want to go to outer space, we're not going to worry about it. If you're just dealing with airplane, we're not going to worry about it. We're going to just say this is a constant. Okay.
Yeah.
So, how do you do that? Let's say at a certain place, this thing is not moving, no friction. Oh, well, let's say no friction. How to solve this one?
Wait, solve for what?
I want to know how this thing gonna do.
You need to know like how fast it moves down that slope.
Actually, when you're talking about this, right? You remember when we were talking about doing these equations? We want to take out the derivatives, right?
Yeah.
So when you solve the problem, you want to take out all the derivatives and get to this.
Yeah.
Right? You want to find this. X is function of t. In other words, where it is at any given moment. Once you know this, you know the velocity, you can just take a derivative of this, and you can know the acceleration, take another derivative of this. Right? So how do you do this? First of all, this thing is not going to move in this direction.
Yeah.
It's only going to move in this direction. Let's say this wedge is not moving. Okay? And this force has two elements of it. One element is going down, perpendicular to this. The other one is going down this one. Okay? Okay? This force has two components of it.
Yeah.
And this component is taken out by the slope.
Yeah.
The slope push it back up. However, before you come down, they push it back up and make sure you don't move this way, right? So this force got balanced out. This force is a force to accelerate this thing, right? This is theta, of course. So what is this force?
That would be sine theta.
Okay, good. No more hesitation. Yeah, in this direction, we call this x direction. This is x direction, right?
Yeah.
This is the acceleration. No, this is the force actually. This is force, and we know force equals to ma, right? That equals to mx2 dot equals to this now, right?
Yeah.
So x2 dot equal to g sine theta, right?
Yeah.
Now, look at this. M is no longer there. In other words, however this thing moves has nothing to do with whether this thing is heavy or light or whatever. You know who discovered this thing?
Yeah,
This
some
property.
random guy who dropped 2 different balls off of a building.
What's that building called?
The Leaning Tower of Pisa or whatever.
Okay, what's that guy's name?
Isn't that the apples? I don't know.
No, not Newton. Galileo Galilei. Okay. All right. Then we probably don't need to do any more, right? This is just the A. The thing is, this is not constant. I mean, this is not moving. This is the constant.
Yeah.
This is flat, right? Let's just say, what if this has a resistance? This friction has a fixed resistance.
Then just divide the acceleration by how much resistance is.
I'm sorry.
Like divide the how much.
Let's say the resistance is resistance is a constant. This is we call this F vertical. It's pressing on it, right?
Yeah.
Let's say the resistance F resistance, right, is a F vertical with a constant. They just call it K. Okay.
Yeah.
Because when you press it harder, there's more resistance. You have that experience, right?
Yeah.
Yeah. Lighter, less. Right? Let's call that. Let's say this is proportional. Right. So, what you have is the F resistance goes this way, right? Right.
Yeah.
So this is F. We'll call this F. Right. So it's F minus F resistance equals to this stuff, right? F equals to this, right?
Yeah.
Then this is mg sine theta minus Fr equals to mx, right?
Yeah.
And this is K to the vertical. What's this force? What is this?
Wait. Is it like the force?
This
It's
one.
like cosine theta.
Right.
I was so
Right.
confused because you didn't like write it on the graph, so.
Okay. So substitute this in, right? Mg sine theta minus K mg cosine theta mx.
Mm-hmm.
See the interesting thing, m still go out. You can still cross cancel m. M is in every term. See that? Still. It has nothing to do with whether this thing is heavy, whether this thing is light. Still doesn't matter. Yeah, of course. One goes down, one goes down this way, yeah. Yeah?
Yeah.
And this is very simple. This is just a different A, all we're talking about. Right? X2 dot equals to G sine theta minus KG cosine theta. Yeah? Same thing. This is a constant. As long as it's constant, it all goes to all of this stuff. All of this stuff works out.
Yeah.
The one of the thing here is that you can remember this. This is the power situation, right? When acceleration is a constant, then the velocity proportional to t, you take one integral, right? Then the distance is the t squared. You took another integral, right? You can remember this. And actually, when you take a physics class in high school, I don't think they put the stuff up. They just tell you this. You go remember it and solve problems. But you know how this come from, right? This is, yeah. Yeah, now it's good. 30 minutes. We we're gonna stop here. See you later.